In this video we will read through the method and identify the control variables and how they will be kept the same for the enzymes and fruit experiment. The method is here, so we're going to read through this and then identify what things we're keeping the same and how we're keeping them the same. So first step is to collect all the equipment that you need for your group. So you need to collect 5 jelly cups filled with 25 ml of jelly, 1 vivid marker pen, 3 pieces of each of an apple, orange, kiwi fruit, banana that have been cut into 1 centimetre cubes, and a piece of glad wrap. Use the vivid pen to label each of your jelly cups with your group's initials. Then take one of the jelly cups, which should be filled with 25 ml of jelly. I'm going to highlight this here because that is a measurement or a value and that might be a control variable. So label one of them with a B for banana. Get your 3 pieces of banana that have been cut into 1 centimetre cubes. That might be another control variable, and the fact that we've got 3 pieces might also be a control variable. Put them in the cup and cover with glad wrap. Glad wrap might also be a control variable, so we'll highlight that too just in case. Label another jelly cup with an A for apple and repeat the steps in step 3. Then repeat steps 3 and 4 for the kiwi fruit. Label that jelly cup with a K, and orange, labeling that one with an O. Finally, label your last jelly cup with a C. That's going to be the control. It's not going to have any fruit in it at all, and it's just going to be covered with glad wrap. So we'd expect that that jelly cup should stay solid. If it doesn't, it means that something else is happening. Put your jelly cups in the grey tray, and those are going to be left in there until next lesson. The following lesson, you're going to collect your jelly cups. You're going to remove the glad wrap from the cup and discard the pieces of fruit into the rubbish bin. Please don't put them on the bench, stick them in the bin. If some liquid has formed in the jelly cup, then you're going to gently pour it into a 10 ml measuring cylinder. That might be another control variable. Then you're going to look at the measuring cylinder from eye level at the base of the meniscus and record the amount of liquid formed. So it says here what you're recording, the amount of liquid formed, so that is your dependent variable, which we've talked about already. And these ones here, these might be control variables. So all the bits we've highlighted in green potentially are control variables. You need to pick 3 to write about. So if we go back to the top, let's pick something. So the fact that the jelly cups are filled with 25 ml jelly, that is a control variable. So we'll say amount of jelly. Because if we had different amounts of jelly, they might make different amounts of liquid or they might remain solid. So how is it controlled? 25 ml used each time. A second control variable might be the 3 pieces of fruit per cup. Amount of fruit per cup. So 3 pieces used per cup. Now if we'd use different amounts of fruit per cup, then we might end up having more solids or liquids made than the other ones, so it's important to keep it the same. A third one might be that the cubes of fruit have been cut into 1 centimetre squares. Size of fruit cubes. So if we had some that were bigger than others, or smaller than others, then it might mean that we could fit more or less into the jelly cup, and that would affect our results. So we'll say fruit has been cut into 1 centimetre cubes. Now those aren't the only control variables. You've also got things like covering with glad wrap. That's important because if you didn't, you might get all sorts of other things happening to your jelly if it's sitting there in the classroom. The mice might get into it, something like that. Using a 10 ml measuring cylinder to measure the amount of liquid runoff, that's a control variable because if you used a different size for each trial, it might give you a different result. And then this one here, this is a way that we make sure our results are accurate. So measuring from eye level, so crouching down so that you can see the amount of liquid at the base of the meniscus from eye level helps to avoid something called parallax error, which you'll remember hopefully from your chemistry experiment. So all of those things could also be included in the control variables.